Class, this is going to be our flipped classroom on mole-to-mole stoichiometry. Now, what I'm going to do is from my workbook, it's an excerpt from page 47, so you can follow along with this video and with the workbook. I highly recommend you pause this video from time to time and work out the problems on your own using a calculator. It's much different than just watching the video. So first of all, what exactly is stoichiometry? Well, it's kind of a fancy word for ratio in chemistry. It is a way to figure out how many grams or how many moles or even how many liters of a substance you have given some starting information and then converting it or changing it or setting up a ratio to find the answer. So for example, I could give you a problem where you will be asked to calculate the moles of a product produced or the moles of a reactant needed given a known quantity of moles to start with. This is simply done by setting up a proportion and then solving for x. So as I said, stoichiometry is really just a ratio. So let's say I gave you this example. This says that 4 moles of NH3 will combine with 3 moles of O2 and it will produce 2 moles of N2 and 6 moles of water. So what we have is a 4 to 3 to 2 to 6 ratio. And that ratio is set. It can't be changed. That is the ratio for this reaction. However, that doesn't mean I have to start with 4 moles of ammonia. I can start with however many moles I want, but the ratio of those numbers must be consistent. 4 to 3 to 2 to 6. So let's say in this example, I'm going to give you the following. I'm going to give you 2.500 moles of ammonia, and then I'm going to ask you to find how many moles of oxygen we're going to need and how many moles of nitrogen and water we're going to produce starting from that information. So how do we do this exactly? Well, this is how we do it. What we're going to do is we're going to set up a proportion. We're going to set up a ratio between the ammonia and the oxygen. And then we'll set up another proportion for the nitrogen and eventually for the water. So let's do that. What is the ratio that we have so far? Well, right now, the ratio between the ammonia and the oxygen is 4 to 3. Let's just worry about that for now. We'll do the rest later. So what I literally can do is I can put a line under the ammonia, a line under the oxygen, and I've already set up a proportion if I just put an equal sign between the two. So what I have is 4 over 2.500 is equal to 3 over x, and then I just have to solve for x. And there it is. 4 over 2.5 equals 3 over x. I cross multiply, I get 4x is equal to 7.5. I divide both sides by 4. This 4 cancels, and I'm left with 7.5 over 4, which is equal to 1.875 moles of oxygen. Now, let's do the same for the nitrogen. This time, we've already done this. Let's put a line under the nitrogen and put an x there instead. So now my ratio is 4 over 2.5 is equal to 2 over x. And I have that right here. 4 over 2.5 equals 2 over x. Cross multiply, I get 4x is equal to 5. Divide both sides by 4. And I get 1.250 moles of nitrogen. And lastly, I can now do a final ratio between the NH3 and the water. This time the ratio is 4 to 6. So 4 over 2.5 equals 6 over x, going down to the bottom of the page. 4 over 2.5 equals 6 over x. 4x is equal to 15. Divide both sides by 4, and I get 3.75 moles of water. So, when I look at the bottom of the page here, instead of having 4 to 3 to 2 to 6, my numbers are 2.5, 1.875, 1.25, and 3.75. And again, these ratios are the same as these ratios. And that's what stoichiometry is all about. So whenever you need to do mole-to-mole stoichiometry, just think of them as proportions. you want to use the original coefficients and then put in x wherever you're looking and find what that x is. And remember, in a balanced equation, those coefficients are set. They don't change. You're just changing what you actually started with. I also want to point out that we didn't have to start with the ammonia. I could have started with the water and found these three x's. It doesn't matter because the ratio is set.